Okay, with testing, we're going to create another new project. This is going to be testing. We'll need main.cbb, functions.h, functions.cbb, and I misspelled that, so it's not going to recognize that as a C++ file. Let me open up my teaching folder. What did I name it? We're going to remove this, and I'm going to rename it, and we'll re-add it. Okay, so we'll need to declare these functions. I wonder if I can copy paste this and not have the numbers show up. Yeah. So I'm not going to implement all of these, but we'll look at probably just get area, the get area ones. Let's throw these in here. So each of these functions will have a actual function that does what it's supposed to do, calculate the area or whatever, and then a function to test it automatically for us. So we're setting up stub functions, and oh, actually, do I have starter code for this? I think I have starter code for this, because some of these are supposed to be broken. Here, just a second. We'll just add this link. So this is the zombie game files. This is the testing files. We'll save that. We'll export it as HTML. Don't mind me, just making this have the link as we should do. It's hard to keep track of everything sometimes. Okay, so I do have test starting code. We'll just copy the functions.cpp. Functions.h just kind of describes what each of the functions are supposed to do, and then main just calls each of those functions. So if we build it, it currently builds. Now, with these are all stubbed, which means that they just return some placeholder data. I'm going to go ahead and... Oh, well, okay, there we go. So since this has an integer return type, I have it returning -1. Same for this one, because if I don't, I'll either get a warning or an error that there is no return statement. So we should at least have something in there. Down here, these are implemented, but they're implemented incorrectly. But we won't fix them quite yet. We'll do the tests first. So the idea here is we're going to create unit tests, or functions that basically automate the testing process. So for instance, with the get area function, this is just a rectangular area. If you don't remember that formula, it's just width times length, or width times height, or whatever. We're doing width, length, b times h. In this case, we have width and length. So we can come up with test cases just on paper by saying, okay, if we have a width of 5 and a height of 3, we are expecting the area to be 15. We can just do that math in our head or with the calculator, and we know this is what should be the output. Width of 7 and 11, I tried to make easy multiplication and also primes. That's a 77. It doesn't have to be primes, but it feels like it'll be safer. I don't know if there's any justification in that. So I just tend to go with prime numbers. So in this case, this can also be reflected in code. Instead, over here, with the test get area, we have an input width and height, and we have an expected result of 15. Then we can get the actual result by actually calling that function. So if we put these in here, we'll just label this as test1. I mean, we should probably have more information, because as you add all the tests, this will get a little cluttered. So we have our actual result. We can set actual result is equal to get area, passing in that input width, input height, I guess it's length. Sometimes I forget to be consistent. And we'll do that. And then we can compare. Now, if we wanted to manually, visually just compare, we could say, let's say input, let's say width is 5. Height is, where did I put that? I meant to put input width. Input height. Area should be the expected result. Area is actual result. So if I run this, I can visually check this and say, okay, this is not doing the math correctly, so something's wrong. But we could also kind of streamline this more because, you know, once you have all the tests done, you'd be looking at these and be, okay, this one fails, okay, this one passes, blah, blah, blah. You have to like visually parse that information, and doing that's kind of tedious. So instead, what I'm going to do is this, where I'm going to check with an if statement if the actual result does not match the expected result, then we are going to display fail. If they do match, we'll display that they pass. So in this case, I have if actual result is not equal to expected result. In this case, I have a little string to make it a little easier for us, so I can keep the result part brief, but then display the result down here. So over here, we'll say result is, and we'll just style it like that so it kind of stands out. We'll add a tab afterwards. Else, in this case, it passes. The reason I tend to put the fail case up here is because with more advanced things, eventually you'll have a lot of cases that could cause it to fail. So you'd have, you know, else if cases. You know, if we're working with arrays, we could say, okay, is the size wrong? Are the values wrong? A bunch of stuff. And those would all be fail cases, and then only if nothing failed, then it would pass. So that's the way I tend to write these. But we just have a really simple thing, and so we can test this out. It'll say pass or fail. We can still display the expected results. So here we see fail. Now, this isn't the prettiest it could be. I like to have very nicely formatted programs. So what I'm going to do is, I basically gave you the formatting for this. We have test name. I'm going to create a string test name up here. We'll just say basically what I have here. And if I run this, this will look a bit nicer. I was inconsistent with my naming in the example. So then we have fail, and then the test name, and then the variables. All right, so let's, with this one test, fix this function. I'm going to come up here. It was expecting a 15, so I'm just going to come in here like the intern I am and set that to 15. Now the test passes. However, if I try a different area, it's always going to give me 15, and that's not right. So that's why we have to have at least 2 tests for this sort of thing. Usually, if the function has like a bunch of if, else if statements, I try to have 1 test for each of those scenarios. In this case, it's just doing a math operation, so really 2 tests should be fine. And we have that other test case. 7 and 11 gives us 77. So I'm going to go ahead and copy these. We are not redeclaring these because we got those. We can just reuse them. 7 and 11. We're expecting 77. And also let's copy this test name. This one is test 2. And we can run this now. Oh, we are not redeclaring the result. And we get this back out. So currently, this one fails. This one passes. So, the math isn't right. It's correct here, I guess, but it's not right here. So We need to go investigate the function. Okay, that's not how you calculate area. So we return instead the width times length. We run it, and now they both pass. And so you'll do the same thing for the rest of these. This will describe what the different functions do. Basically, with string length, this one should return the amount of characters in the text string. If we look up C++ string, the string object, the string class has a size function, so you'll just use this. And here's an example of the size of the string is str.size. str is the variable, and you'll use that here. But don't implement the function first, implement the test first. So with test-driven development, you can also look up, let's see if this gives us test-driven development, or if it goes to, okay, yeah. The idea is you write the test first, and it should fail because you have stubs in place. And as you implement the functionality, you should get, your tests passing. So you start with the baseline of the tests fail. That helps you define what is correct, what is a valid function result, and then you pass the test. So that's just a design philosophy. Most places don't do it from my experience, but I like approaching things that way. Now with get parameter, I've implemented the incorrect formula here, so that should fail the tests. Withdraw, incorrect logic here. So you should implement the tests, those should fail, and then that would give you the hint that, yeah, those need to go be fixed. And with unit tests, usually in the real world, at least in a lot of places I've worked, as we implement a new feature on the back end with like C++ or C#, we then go add unit tests or other types of automated tests as we're doing that development. So they kind of go hand in hand. As a side note, there's one place I applied to and interviewed at that said, yeah, we don't do tests because that's extra code to maintain. And I was like, yeah, I'm not going to work here. It's good to have tests. It's good to validate that things work, especially if you're in a monetary-based software business. But yeah, so that's how that will work. And then now I want to talk about Git here in a moment on a different video.